Hello and welcome to the Disruptive Innovation Festival 2017. We are week 2 out of this 3-week online festival. This year we asked the question, what if we could redesign everything? My name is Francois and I'm part of the Business Insights team here at the Ellen MacArthur Foundation. And coming up this show, we know more about what goes in our food than what goes in the building we spend most of our time on and how Google is working to change that. The DIF is an interactive festival, which means that throughout this session, we want to hear your questions that you can post either in the chat box below this video or on Twitter using hashtag ThinkDiff. To answer the question, today we are joined by Robin Bass. Robin is part of Google's Real Estate and Workplace Services team, and with her team, they are responsible for delivering health and sustainability outcomes for Google's over 70 offices in 40 countries. Hello, Robin. Thank you very much for joining us. So for most of us, Google is mostly famous for its search box. So why did you get interested in the built environment?
Well, like you said, Francois, we have offices all over the world, and it's really a company where the engineering culture and the culture of curiosity and the ethos around product development that exists for the company, focus on the user and all else will follow, is a big mantra that you'll hear often in Google product development circles. And that extends to the real estate group. Our product is the building, and if we focus on people first, our thinking is that the outcomes will be great. So I was going to jump into a little bit of an overview of what the company is doing around sustainability as a whole. And you know, it's not just about people in the buildings. We do a lot of work on traditional sustainability areas, certainly in our data centers and focusing on energy. Since 27, we have been carbon neutral, and in 2010, we began buying renewable energy at scale. Today, we are 100% renewable energy, and that means we are supporting renewable energy projects that offset our traditional energy consumption from the grid. We also support and build products that allow homeowners to see their roof area and connect with local solar suppliers and recognize the rebates and solar potential from their roof in real time. And we also are very concerned about waste and have a zero waste to landfill goal for our data centers. And right now we're tracking at 86% of waste from our data centers that's being diverted from landfill. And just last year, our data center in Mays County, Oklahoma, was the first data center to achieve zero waste to landfill. And we're really proud of that. We also look at waste in our offices, and in our Bay Area campus, which is our largest campus, we have an 86% diversion rate. And through annual waste audits, we know that a lot of that waste is coming from our cafes. We have over 27 cafes in our Bay Area campuses, and they generate a millions of pounds of food waste. And we've worked with the city agencies to make sure that we have a robust composting program so that is no longer waste, but it's being turned into fertilizer and food. We're also big systems thinkers. We're a culture of engineers, and certainly our data centers, we look to build our own equipment, maintain that equipment, refurbish it whenever, as long as we possibly can, redistribute it to other users, and then ultimately recycle it at the end of its life cycle. Our data centers are 50% more efficient than the industry average, and we've had a 40% reduction in energy used for cooling, leveraging our machine learning algorithms. But what I'm really here to talk about today is our perspective on health and why Google cares about health in the built environment. And it gets back to that mantra that I spoke of at the beginning of our talk, where we really want to focus on the user. And if you think about people first, and if you think about how frequently Google is accommodating growth, we move people on average every 3 months to accommodate team growth. And when you're moving people into new spaces that quickly, people start to ask questions about what's in those new spaces and why they smell things differently in those new spaces. So people really, it's what makes Google different in the industry is the focus on people. And when you look at these kind of statistics, we spend 90% of our time indoors, and a significant portion of that time is at work. And the science is certainly starting to back the idea that we should pay attention to what's in the indoor air. There have been some great studies coming out of Harvard University. There was a cognitive effects study that came out in 2015 that's available online, that anyone can look up and read through. It's very compelling, and they made the case for what toxins and building products do to your ability to think. And it was a great thing for me to point out to our executives and say, look, we are in a talent war. We are trying to hire the best and brightest and have them solve the hardest problems in the world. And why in the world would we put them in boxes where they can't think? So we know that the chemicals that are in our building products have an impact on our health. They also have an impact on our ability to think. And this is another big problem. We know what's in our food. You can walk into a grocery store and you can look at the nutrition label and you can make an informed decision about your health. But you cannot walk into a hardware store and make the same decision about building products. So in 2010, that's when we really blew up in terms of building out new spaces really frequently and growing our teams exponentially. And it helped that the most curious engineer was Larry Page, and he happened to have a particulate counter in his backpack. So when Larry Page pings you about smelling something different in the space, you want to have a good answer for him. And the truth of the matter was that we didn't have good answers for him, but we thought it would be a really simple solution. And so we built a spreadsheet. We started in a really analog fashion and thought we would just go out and ask manufacturers what was in their products, and they would tell us and we would move on. That's not the case. I'm still here today in 2017 talking about healthy building materials and working on this really complicated problem. It turns out that we are breaking spreadsheets left and right. When we started, there are just way too many products in a building project, and there are way too many complicated supply chain issues for us to try to address this with a simple off-the-shelf solution. So we needed to build a software platform that could get people out of the way and leverage technology to help us build a library of products and build a framework for how we think about and how we help manufacturers see the road forward to optimizing for human health. So in 2014, we partnered with the Healthy Building Network and we built Pontico. And today we have rolled that Pontico tool out to other leaders in the industry. So not only is it Google and Healthy Building Network, last year we formed a partnership with Harvard University, the Durst organization, which is a large East Coast North American real estate holding company. Perkins & Will, one of the largest international architecture and engineering firms. And the most important partner, I feel, is Home Free Affordable Housing. These building products and the toxins that are in them are often, are often in environments where people have very limited ability to do anything about them, the most marginalized communities. So there is a social equity component to this work as well. We know that if we're solving this problem just for Googlers, it's a failure. It needs to be a solution for the industry and it needs to impact everyone. So that's why we're bringing Pontico to the industry. This work that we're doing with our partners is to bring Pontico to a tool that is open source and available to the industry. So that is our goal. We're also making decisions at a much different scale in the built environment. This is an aerial view of our new campus in the Bay Area. And historically, we have been the most successful hermit crab in history. That being, we have moved into other people's shells and made them as nice as we possibly can. But we're about to be a big land developer. And that allows us to solve a lot of sustainability issues upstream. And so we're looking at new product category areas that we haven't had to deal with before in the interiors of buildings. So products like concrete. Concrete has a bunch of problems with it, and we will be a huge consumer of concrete in our new development projects. But it is a 1-to-1 ratio for cement in concrete mixes and carbon. And it's also a heavy consumer of waste products from coal-fired power plants like fly ash and slag. Now, you can look at that and say that's a good use of recycled materials. But Google's analysis of fly ash and slag from a health perspective raise a lot of questions. There are significant amounts of heavy metals, mercury, arsenic that show up in concrete. And to assume that once those materials go into the concrete, they are encapsulated is a false assumption. Again, I would point to the science and say that we've examined dust in buildings and know that these heavy metals are showing up where they shouldn't be. So we did a study, a partnership with the Ellen MacArthur Foundation of how we could solve some of these problems around concrete by leveraging a recycled material that doesn't have a good second use stream right now in the United States. Glass bottles, glass fines, particulate glass. And so we wanted to see if we could use ground glass, which becomes glass pozzolan, in concrete instead of fly ash and slag. And we are really excited to announce that development project that we're working on will be piloting glass and concrete in it. And this is the slide that I like to end on because I love to talk about my kids. I have 2 young boys, and they're soccer players. So here they are on their soccer field. And it's also a cautionary tale about circular solutions. If you look at that middle image on this slide, you can see the ground rubber material that's in there. That's old tires. And the people that set out to build this playground were not intending to hurt little kids when they did it. They were trying to solve an issue with using real grass, which creates a water problem. When California was going through a huge drought, they started putting down this fake turf in a lot of playgrounds. But what we've realized is that we've created an even bigger problem for ourselves, because when the kids spend several hours on these playing fields, they stir up all of this ground tire crumb. And what happens is all of the particulate matter that was on those tires gets into the air. And they're heavy particles, so that mix stays at about 3 feet off the ground. It's right where kids are. And so they come off the field with bloodshot eyes, with runny noses, and with asthma triggers. So it's something to be aware of. We need to know what is in the stuff that we're making circular. We need to understand what we're putting back into feedstock and use streams before we assume that we've solved the problem and not created a much bigger problem. So we're excited to be digging into these meaty issues at Google. We know we're not going to solve them alone. We're looking for others to help us. And this is my favorite quote. This is what we're really trying to do. We are trying to build a new model that makes the old model obsolete. In the vein of redesigning everything, it's an exciting opportunity and a daunting challenge, and we're excited to be working on it. That's it.
Thank you very much, Robin. Fascinating to see all the things that are happening at Google, and I think it's sparking a lot of questions from the audience. But before we go to address those questions, I'm going to hand over to Molly, who is going to tell us more about what's coming up with DIF.
Thank you, Francois. And hello to our lovely audience online. So tomorrow at the DIF is going to be a corker, and there are 3 sessions in particular I'm really excited to tell you about. So at 3 p.m. GMT, join us to discuss how we can apply circular economy to something that life just can't survive without. And that is water. And then at 4 p.m, we'll be hearing from the lovely folks at Schumacher College to explore what we can learn by applying ecological wisdom to innovation. Interesting. And then straight after that, we'll be saying hello to Simon and Alex, who will be checking in with all you keen designers and system thinkers to answer your questions about the first ever Circular Design Award. So if you're thinking about entering that competition, this is a fantastic opportunity to fine-tune your projects, so don't miss out on that one. And then if you're not around to watch the diff tomorrow, here's one I'm looking forward to next Wednesday, and we'll be joined by award-winning ecologist and architect Ken Yang to explore what a city as vibrant and healthy as a forest might look like. And although you may not be around tomorrow to watch the diff, do remember you can catch up on all the sessions you've missed, and even the ones you want to watch again, by going to thinkdiff.co. And although I wish I could recommend you a way more diverse group of sessions, don't forget you can follow us on our social media accounts, so at thinkdiff.co_, and you'll be in the know of all the great sessions we have coming up and when. And remember, this is a conversation. We love to hear what you guys have to say, and the easiest way to do that is to use the hashtag ThinkDiff, and we'll be keeping an eye out on our social media feeds for all your great comments and questions. So thank you everyone at home. Back to you, Francois and Robin.
Thank you very much, Molly, and welcome back. We are discussing with Robin Bass from Google on Google's approach to health and circularity in the built environment. And after a great presentation, we are going to dive into questions from the audience. And the first question that can be thought-provoking is, Google is a company that is used to operate in the digital space where everything moves very fast and you can remove the past and go to something new very quickly. And the built environment is very different from that. And how much of a change in mindset was it for Google, and how hard do you find it to disrupt the built environment?
That is a great question, and you're spot on in your observation. This is a company that gets very, very frustrated with the lack of change in design and construction. And I would say construction in particular is a field that is ripe for disruption. And certainly when we apply circularity and to the built environment and think about things in a different way, designing for deconstruction, and challenging contractors to think of themselves as movers instead of a demolition team, it's a very, very interesting conversation. And it's, wherever there are people involved in a process, it takes twice as long as you would want it to. But we really try to bring all of our stakeholders to the table early and get them involved and bought into the process and the disruption that we're trying to create. And, there are also, when you bring people along like that, you can also find new business models and models that they don't see today, but that they can think about for the future. And that example where we're working with contractors to have them reframe the beginning of a project from demolition to deconstruction and moving is a great example. So how do they become a moving and storage company for resources versus a demolition and landfill hauling company? So that's one example. And I would say another example is on the campus building that I showed, we are required by code to build a large parking structure. Now, our leadership is incredibly frustrated that we are going to have to spend millions on a parking structure that we know will be obsolete in a matter of 5 to 10 years because of the autonomous car. So we're thinking about the design of that structure that we're required to build in a way of what could it become when the autonomous car makes a parking garage obsolete? Could it become housing? Could it become another office building? How do we build that building in a way that we're thinking about its future and planning for that today?
Okay, well, thank you. It's a great way to look at things than to change the title or the action of people do and reframing it through a circular angle and other angle, thinking about demolition people more material movers. And another question we have from Marco is around regulations this time. And And the question he has is, surely there are some regulation about toxicity in the built environment, and why did you still feel the need to enter that space?
Well, you'd be surprised at how little regulation there is on chemicals and how little we know about the chemicals that are in our spaces. And I would say in our consumer good products everywhere. There are over 80,000 registered chemicals, and only 5 of them are regulated in the United States. So, there's not that much regulation, and certainly with the political climate being what it is in the United States, we anticipate that there will be even less regulation going forward, with more new chemicals being created every day. So, it's an effort that aligns very strongly with Google's mission to organize the world's information and make it universally accessible. This is a space where there's no information, and that lack of transparency is, it sticks in the craw of a lot of Googlers. We believe that information should be public and available to consumers. We should be allowed to make informed decisions about the products that we're using. And manufacturers benefit by knowing what products and materials they're putting out in the world so that they can design a system and a process around circularity that allows them to take them back in a thoughtful way.
Oh, okay, so one other question that could spark from that is, if we see buildings as potential material banks and we know more about what's in them, how can we ensure that at the end of life we ensure that it's a healthy building, that we can recover the materials? How can we ensure that we have a proper identification of those materials at the end of the building life?
Yeah, well, I know there are tons of people working on technology solutions for that, and it's something that is easier to design into a new building. It's something that we are looking at for our new campus buildings, but the reality is we have an enormous building stock of existing buildings in the world. And what do we do with all of the uncatalogued materials? How do we recoup some of that value as we take those buildings down, or as we, deconstruct them to have a new use for the future? It's a difficult problem to solve. And I think that without the thought and leadership of designing that into your materials and really thinking through the end of the life as you're designing the beginning of the life of your building, we've created a real a knothole to work our way out of with all of the building materials that are uncatalogued and living in our existing space. That's represents millions and millions, if not billions of dollars of value that we will be unable to recoup if we're not thoughtful about how we take those buildings apart. So I don't think I have a good answer. But I know that it's something that, as we look at all the existing buildings that we have in the Bay Area and elsewhere, certainly we're a much larger owner in the Bay Area, which gives us much more control. How do you retroactively go back in and catalog materials and make sure that they stay in use streams? It's difficult, but we are, the glass and concrete work that we did has really highlighted that there's a lack of infrastructure to make those second use streams really come to life. So it's not the sexy part of the problem, but that's the part of the problem, creating the infrastructure that we really should address. Like, what is coming out of buildings? How do we put those into second use streams?
And through the life of the building, often the shell will stay, and you'll have several refurbishment, and it's something that happens very often, especially in the Silicon Valley, where a lot of old buildings are reused. I know that the Google campus has currently a lot of building that you guys moved in. One question there could be, what's the role of refurbishment in actually making buildings progressively better?
Absolutely. Well, I mean, that's been our history. Like I said, we've been a very successful hermit crab. All we have done to date is move into other people's shells and try to make them great. And, I think that it's the mentality for developers really needs to shift. And the way that we assign value to real estate really needs to shift. Because what we wind up inheriting is a building with an ROI of 3 to 5 years. And the kind of systems, both from a base building system and an envelope design that you get with that kind of ROI are really, not high performance. It's a very low common denominator that we often find ourselves having to it's a very expensive case to try to retrofit an envelope to support your goals for indoor air quality, or to retrofit an existing base building system that was not designed to deliver high quality air to the occupants. A lot of times what code allows you to build is in the United States, I would say we have a lot of catching up to do with our counterparts in Europe.
And one question we have from Haley in the audience is, what could be the role of new business models in actually creating incitations for the developers to move to more circular models?
I think there is a huge opportunity. I see the circular economy as being an enormous jobs driver and industry driver. I think that anyone that looks at a linear model and doesn't see the absurdity of it and doesn't see the opportunity to recoup value, I just think the more that we have people building out those business cases, the more business will gravitate to where the money is. And I certainly think that we endeavor to bring our stakeholders that are working on our development projects into that conversation and have them reframe the function that they're trying to fulfill as part of their job.
Okay. And another question we have, because when you presented the case of glass in concrete, one of the core arguments of that question is also how can we make use of a material that's local and for which we don't have any solutions. And one question we have is, what's the role of local materials in that picture also?
That's a great question. And, when we started looking at the glass and concrete issue, we realized how local these issues are. Waste is incredibly local. You have to really dig into what are the city policies, where are the contracts with haulers, and what are the waste streams that are available to recoup and build back into a second use stream. And what we found, ironically, we thought that we had this big recycled glass problem, and we know we do. All across the United States, there are millions of tons of glass that are being recycled and ultimately taken to a landfill because there's not a second use stream, because it's such a heavy material to transport. But in the Bay Area, we have really strong legislation around bottle bills and recycling policies that turn all of our glass bottles back into glass bottles. So we didn't want to compete with a very circular solution that was already in place. So we had to look at nearby communities that did not have that same infrastructure in place, where we could still say that we were solving a carbon problem. It was close enough. If we had a facility in, say, Sacramento or in LA, that's still close enough to say that we're making it's a regional solution. But it's incredibly local. And I would say the partner group that was helping us dig into this issue in glass and concrete was on the East Coast in New York. And their issues were dramatically different from ours. And, it just goes, I think regional materials will play a huge part in the circular economy. And to me, it's an exciting thing to think about from a designer's point of view. There is such a homogeneity that comes from mass-produced materials, but if we start thinking about some of these regional materials being put back into regional markets, it could build a resurgence of kind of leveraging the genius of the place and really leveraging regional materials into presenting more of an iconic regional architecture.
And if we follow that thought about regional material and the reuse of material, Have you ever experienced trade-offs between creating healthier materials and their potential reusability? Like, do they make more healthy material maybe more brittle or harder to recover? Is it a trade-off you've experienced?
Well, I would say we haven't experienced that trade-off. You know, a lot of times when we try to, the feedback that we've gotten from manufacturers is that the chemical chains in some of their materials are really complex. And when you start mixing two synthetic products together, it gets really difficult to separate those two things back out. So, and we've always found that manufacturers that understand what's going into their products have a much easier time. It's still a difficult problem, but it's a much easier thing to understand what you can rebuild at a molecular level in a second use case by recouping that material if you know what's in it to begin with. So the health argument in building products supports circularity. It really is about safe materials perpetually cycled, and knowing what's in your product allows you to evaluate whether it's safe, and then how do you perpetually reuse it.
Excellent. So asking constantly the question, what's next for that material? We have a few more precise questions. The first one is from Sophia about Pontico and about what is the future of that program.
Well, Portico is a tool that we've now leveraged on Google projects for several years. And as I said, this past year, we have been working on it with a group of thought leaders and collaborators that are already really invested in healthy materials. We want to ultimately bring it to the industry and have it be a tool that the industry can use. But I would say the biggest challenge for us right now in doing that is a lack of quality data. We really are still struggling with, having a robust enough library where a designer can go to the library and have options. Ideally, you would want 3 or 4 options to choose from. And in some product categories, we don't have anything yet to choose from. So I would say that, we're looking at strategic ways to continue to move the market and to create more of a demand signal across more companies. So that there's clarity for the manufacturers on what we want, that they should be optimizing for health and what standards they can use to deliver those outcomes. But it's a really tough onion to peel. The challenges for a manufacturer who sells planks of wood for flooring or wall covering are really different from a manufacturer of elevators, where there are literally 3,000 different components and 27 different suppliers. So it's really difficult. But I would say our goal is always to increase the circle of users year over year, so that we do continue to build out functionality and we do continue to increase that demand signal to the market. So I would say, stay tuned as we widen the circle next year. But we're really not ready, or we're really not at a place where we can bring it to the industry yet.
Okay, and you talk about evaluation of material. Can you give us a sense of the criteria that you are using to evaluate those materials?
Absolutely. So that's a great question also. When we started, it was really a binary issue. We were using lists of banned chemicals from the EPA and the Living Building Challenge. And what we found was that the binary question, do you have these chemicals in your product or don't you, was a yes or no answer. It's not a conversation, and it creates there's no reason to collaborate. You're either in or you're out. And that's not what we want. That doesn't further the mission of optimizing for human health. We really need people to stay on the journey. And so what we created in 2012, we gave a $3 million grant to the United States Green Building Council. And that grant was an effort to harmonize across the industry. So to get third-party rating systems and third-party standards for material health aligned on the notion of inventory, screen, assess, and optimize. So that's really the pathway that we've created, and those are the criteria that we use to create the scoring mechanism in Portico. So the farther along that you are in that journey, the higher your score will be. And so our goal is to continue to push the market and kind of leverage healthy competition and kind of saying, hey, your competitor just got a higher score in Portico. Don't you think you guys should really work to get that XYZ chemical out of your product? That's the framework that we use to create a conversation and to acknowledge and reward people for where they are in the journey and encourage them to continue to do more.
Excellent. Well, thank you. Another question we have is from Jennifer asking, how do you see Google's role in the built environment? Because you seem to have a much bigger ambition than being a solely buyer of construction services.
Well, like I said, we are a company that's not afraid of tackling big problems, and we have a global real estate portfolio, so we can't have solutions that work in just one location, and we can't have solutions that just work for Google. We really do endeavor to hold to an industry standard market for our budgets on our projects, because we think that if we're solving something by deploying a new technology that only Google can afford, that's a solution that doesn't scale, and that doesn't make anyone at Google happy. If we're solving a problem, we want to be solving it for everyone. And so I really feel that to the extent that we can be a mover for market change, that's really what we want our role to be in the built environment, and in specific areas where we can be a leader and where it's aligned with our mission, for example, the material health work that we're doing.
And around that notion of global scale and impact, we have a question from Seb around what are the main barriers or difficulties that you face as you try to improve building health globally?
Great question. There are so many challenges, I almost don't know where to start. But we started our pilot program on material health on our Bay Area campus, and we are a very big player in the Bay Area. We have a very big real estate portfolio. It's growing all the time. So that's a big lever for us to pull with manufacturers to say, we want you to satisfy these material health criteria, or you could potentially be missing out on, whatever dollars are attached to that sale for their material. And we've definitely done material challenges for manufacturers where we kind of say, hey, the first manufacturer to eliminate brominated or fluorinated chemicals from their product will get, the next X million square feet that we're building out. That's an incentive that we can do in the Bay Area. It's different in the rest of the world where we are often leasing office space. We don't own the offices, and we're one of many tenants in a building. So that's when we really realize that it's not, this is a solution or a problem that Google can dig into, but that we're never going to solve on our own. We really need 100 Googles. We need 100 companies asking questions like this and demanding manufacturer information on what's in their products.
And what is that, to give us a sense of perspective, what is the number of Googleans that you have in the Bay Area, and what are Google's real estate development ambitions over the next few years?
Great question. I believe we're at, oh boy, this is always a tough, the statistics, if you go to our environment page, if you Google Environment Report, you'll go to a public page where I believe we disclose what our real estate holdings in the Bay Area are in square feet and what our current headcount are. But I believe we're around between vendors that are on site every day and Googlers in the Bay Area, we're around 40,000 people. And there are millions and millions of square feet attached to all of those people. And certainly we're publicly now in 3 different cities. We're in Mountain View, California, we're in Sunnyvale, California, and we're in San Jose, California. And those 3 communities are very close to each other. And the exciting part of having a linear campus that kind of sprawls across 3 jurisdictions is an opportunity to say, hey, we want one policy on composting. We want one strategy around waste diversion, and really act as a convener to bring those 3 jurisdictions together to look at resource flows in a really up-leveled way, in a district scale way, because things like waste and water and energy all need to be looked at really at a 30,000 foot level, and not, where dotted lines that separate different jurisdictions end and begin, because we all know that resources ignore those lines anyway, and solving things like resilience and climate change will not be done if we don't all come together and work on this. So having a campus that spans across that many communities, we have an obligation to be a good corporate citizen, be a good neighbor, and help these communities solve for these problems.
Well, thank you very much, Robin, and I think that's a very nice line on which to end. And thank you for this very insightful view on Google's perspective on how circular economy and health actually work together in the built environment. I've really enjoyed that conversation, and I hope our viewers too, from the amount of questions we received. I'm pretty sure they did, but we have to bring it to a close now. If you want to learn more about Robin, you can check her biography on the page of this session. You can also find sessions that are related to this one if you enjoyed the topic and the conversation, or look at thinkdiff.co for hundreds of sessions about a variety of topics. And please join the conversation on Twitter using the hashtag ThinkDiff. See you next time.